Alright, now that we have our keys correctly done, we're going to move on to making it so that this screw can actually fit through this hole. This is going to make a lot of changes from what we originally had. That's going to add, so to do that, we're going to have the screw come all the way through to this side of our jaw. And then we're on that side of the jaw, we're going to have to make it so that the screw can't come back through the hole, but also can't go forward through the hole. So we have a couple different steps here. First off, we need to edit our jaw so that we have a hole coming through, and we're going to also place 2 screw holes there, which you'll see in a little while we're doing that. So I'm going to double click on my jaw to edit it. And first thing I'm going to do is just delete this hole. I no longer want it. So I'm going to find it in my browser, hole 5, right click, click delete, and there it is. It's gone now. Now we need to place a hole on this side, so we're going to click on hole, click on this side, and I want to center it on the same axis again, so I can just come back here and click on the outline of the circle to center it. Now, on this side of the screw, we're going to have a special kind of thing called a retaining ring that'll hold the screw in there. So we need to give it room to sit in there. So to do that, we're going to have a counter bored hole. It's essentially a large hole on top of a smaller hole. Now my distance is going to be through all because I want to cut through everything. We already know this diameter is 0.375. The smaller diameter's hole is 0.375. We're going to do a larger diameter of 0.95. And then the depth of 0.25 is perfectly fine. We can just leave that there. So I have a large hole that has a diameter of 0.95 and has a depth of 0.25. And then in the middle of that, I have a smaller hole with a diameter, actually that's supposed to be 0.625, going all the way through it, just as we see here. So I'm going to click OK, and there's my hole. Now we need to put some screw holes on there, and that, if we look at my Vise with all the changes made to it, that's going to be what mounts these little plates on it. So if I hide these, you can see those screws go into holes right there. So you see those screws there. So we're going to then go ahead and add those. So I'm going to create a sketch on this surface. And I'm going to just put 2 points there. Doesn't really matter where. And I want to make them in the same plane as the center of the circle. So I'm going to go up here and click Project Geometry. Oops. And click on that outer circle to get that center point. Then I could just use a horizontal constraint and make them both horizontal to that plane, or that point. Then I'm going to do a dimension from the point to the edges, and I'm going to make this 0.75 inches. There we go. So I'm going to click H on my keyboard to get to the hole tool. I no longer want a counter bore hole. I want this to just be a regular tapped hole. So I'm going to change my distance and then go down here and click my tapped hole. Now earlier we had a full depth tapped hole. We're not going to have that anymore. That's a much more complex thing to do in manufacturing. So typically we have a larger hole, or a longer hole that isn't tapped than the regular depth of the hole. Now we're going to change our size. We're going to just use a number 10 screw here. It's a fairly small yet strong enough screw for what we need. And we want our thread distance to be 0.5 inches, which will automatically set what the rest of the hole's distance is compared to what's a good amount of distance past that. So I can click OK, and there are my holes then. And if we look really carefully, we can even see the thread stops at some point, and there's the rest of the hole. Okay, so this is all we need to do to this part. So I'm going to click Return. And we have this error because that constraint we had with the the screw going into the jaw no longer exists. So I'm going to just click accept and then find it. It's the one with a little error message, and I'm going to right click on it and delete it. We don't need it anymore. Alright, so now we need to make our screw so that fits all the way through that hole to our side. And to do that, I'm going to need to add some distance onto it. So I'm going to measure by clicking M on my keyboard to get to the measure tool. And I just want to measure from here to here, figure out how much longer I need to extend my screw. So I need my screw to be 1.75 inches longer from this inner part here. So I'm going to double click on my screw to edit it. And I'm going to go edit that revolution by clicking the plus next to revolution and double clicking on the sketch. So first thing I'm going to do before I forget is extend that distance by 1.75. Now this 0.5 here we're going to get rid of later, but I only really want my screw part to be 1.75 longer, so I need to subtract it from that 0.5 there. So this will be 6.5 plus 1.25 inches will give me my total distance that I need. Now I'm going to go ahead and delete this 0.5. I'm going to zoom in and delete these lines here. I don't need them anymore. Now I can't select this line because it's only letting me select the dimension line, but I need to delete that line. So I'm going to right click and go down here and click select other. And that allows me to select anything that I'm near. And I want to select the curve, which is really just a straight line, and delete that by pressing delete on my keyboard. Now I can just drag this line forward, and it can go further than it needs to go. It doesn't really matter. And then I draw a line from my origin up until I intersect. And then I'm going to just go to trim and trim away that line. And now we just have a straight flat area. Now, we're not done though, because we need something, or we're going to use something called a retaining ring to go and lock that shaft in there. So if I go to McMaster, I have an option here called retaining rings. And there's all kinds of different options, and we're going to go with an external retaining ring here. Now, I can narrow down what I need, so I don't need it in stainless steel, so I can select steel. And then we know our shaft diameter is 5/8 of an inch. So I select 5/8 of an inch. And it gives me two options, and I can get in black finished or zinc and yellow chromate. We're going to just go with black finished. And if I click on that, not only can I buy it, but I can click on product detail. And it'll give me this whole CAD and drawing thing of everything I need to know about it. So a retaining ring essentially keeps the shaft from moving in and out of a hole. And by doing that, we first have to put a little groove in the hole. So if this is our shaft here, or you can see in this picture, here's our retaining ring, and there's a little groove that's sitting in. So this groove needs to be 0.039 inches wide, and it needs to have a diameter of 0.588 inches. So we need to add that groove there. So to do that, I'm going to just draw a rectangle, doesn't really matter where, and then go ahead and dimension it. So we saw the diameter of it was 0.588, it's a pretty small groove, and then the width of it was 0.039 inches. And it still has a green line because I can still make it move back and forth. I'm going to place it 0.125 inches away from the front. So now I have a box that we can cut out to create our groove. So I'm going to finish sketch. Now that groove doesn't show up because I need to revolve it. And the easiest way to do that, I could add this revolution, or I could just make another revolution. So I need to first see this sketch, so I'm going to right click on the sketch and click share sketch. And then I go to revolve, and I can select that box then that I want to cut away. So I cut on my options, and then I need to pick the center axis. Click OK, and there's our cutout. Then I'm going to just right click on the sketch again and uncheck visibility so that we no longer see it. And there we have our groove. Last thing I want to do to this is I want to chamfer it. So it's a sharp edge right now. And I want the distance to be 0.05 inches. So, or sorry, 0.01 inches. It's a fairly small chamfer. It's really just a safety feature, so we don't have a sharp edge there to cut someone. So I click return, and now I have a grooved edge on there. So I need to place that retaining ring, and just like we did the set screws earlier, I can place that from the Content Center and have Inventor create it for me. So that's under shaft parts. I have all these different options, including a circlip, which is also a retaining ring. I want an external one. And this very first one is exactly what we need, an ANSI B 27.7M. So double click on it. And I'm going to come in and I'm first going to select the cylinder, so that little groove that we drew. And then I'm going to select the back edge to place it on, and click the little check mark, and there's a retaining ring. Now I don't need to place another one, so I'm going to just press escape on my keyboard, and we have a retaining ring in there then. Now this retaining ring will sit flush back against this wall, so I'm then going to constrain that. So I'm going to go to constrain, go from that wall to this side of the retaining ring. And it's just going to sit in there freely. So now, when my screw pulls back, it'll pull my jaw with it, but I still have nothing to keep my screw from just going forward if I were to make this in real life. And that's what these holes are going to be for. Remember, we have these little plates. Not only are they sacrificial in that I can drill in them and it won't really matter if I damage them, but also they're going to be the wall kind of that keeps it so that when I push forward, it'll also push the jaw forward as well. So that means I need to create a new part. And one of the cool things about assemblies is I can create the part within Inventor, or within the assembly mode. So if I go up here and click create, it allows me to name the part. So this is going to be, what did I name it earlier? We'll just name it jaw plate. And I need to select a location to save it in. So that's going to be in our H drives, our engineering drawing folder, our Vise folder. Right here is perfectly fine. And click OK. And now I have a part created. So I need to select what surface I want to start that part on. I'm going to start on this face here. And we can start drawing a sketch. So I'm going to go to Start 2D Sketch. And we want to start on our front plane, our XY plane here. Now I'm essentially just going to make a square from here to the other side of the jaw. So to do that, I'm going to project the geometry of the jaw. So there we have our square essentially. Then I can use the rectangle tool to make it. And there we go. That's all I need so far. So I'm going to extrude that out. And I want to extrude every part of it, so I'm going to select the circles too. And I'm going to change my distance to be 0.2 inches then. Then we just have to add those holes for the bolts here. So I'm going to create a new sketch on that front surface. And I need to then, again, project the geometry of that back surface. So I can select the easy way to select it is select the lower part of it down here. Oh, there we go. And now I have points where, or the holes where I can make my points. So I'm going to go to Hole Tool. And this is going to be a little different. We want these screws to sit totally flush with these jaw plates. So I'm going to select a countersunk hole, which has a little V cut out of it. And then also, we don't want these things to be threaded. We actually want what's called a clearance hole. And that allows the bolt to easily go through it. So I'm going to select clearance hole. And then I'm going to go down here to size. And we earlier selected the number 10 thread. So I'm going to select the number 10. And that automatically makes every distance up here what we want it to be. So A number 10 thread or bolt uses a .201 diameter clearance hole. It doesn't really matter how deep it is because we're just going to 0.2 inches thick. And then these two things are automatically set for number 10 as well, so that's exactly what I need. So I just click OK, and there are my holes. Easy enough. Let's change our material. These are often made in bronze. It's a soft material that won't damage something else. And then the last thing I want to do to this is, if you look at this version, I have a little V cut out here, and that's so that we can clamp pieces of metal in it. So I'm going to create a sketch on the side, and I'm going to project that geometry so I can see exactly what I'm doing. So I have a yellow line outlining everything. I'm going to just draw the little V shape then. I want to make sure these lines are perpendicular to each other. So I'm going to come up to my constraints, select a perpendicular constraint, and go from one to the other. And apparently I already made them perpendicular when I drew them, so that's good. So then we can go ahead and dimension them. I want from one end to the other to be 0.2 inches. From the top to the bottom, or from the very top, I want it to be also 0.2 inches. And then I want it to be 0.075 inches deep. Now we can see the lines got screwed up here. I can fix that by just making them parallel to each other, or equal to each other, and that didn't work. So let's figure out why. We're trying to make them equal first. There we go. Oh, and if these are 90 degrees, I won't be able to set a depth just due to math. If this is 0.2 inches and this is exactly 90 degrees, it'll essentially use trig to find that line there. And that's all we need. So let's extrude that then. So I'm going to just select that and go to cut, and I want my distance to be all. And there we go. It cuts it all the way through. So let's click return. And you can see that part is now made there. Now we need to place another one on this side. And to do that, I first have to place those holes that we did earlier on our jaw. So I'm going to double click on my base. And I'm going to create a sketch on that surface. Now I want to make sure those holes line up exactly with this side. So I'm just going to go ahead and use my project tool and project those points to it. And select point tool and select the center points. And now I can click on the hole tool and do 2 number 10 holes that are 0.5 inches deep for the thread. And that's all I need to do. So I click OK, and there's those holes. So we click return, and then I need to place another jaw plate. Because we made it, I can click on place up here. And let's go back. Oh, and before we can actually place it, I need to just save my parts, and I'll save my jaw plate. So this menu that comes up essentially is saying, do you want to save these files that were changed? And initial save means I'm creating the jaw plate to begin with. So I'm going to click OK. That'll save all of them and create the jaw plate file. Then I can click place, and there's my jaw plate. So I'm going to place one, click OK, and then let's go ahead and constrain it. So I'm doing this part quickly because by now you should be able to make these simple constraints so that that locks in there. So now, once we place the hardware in there, when I move this, the screw will either butt up against my jaw plate and make it move forward, or pull up against the retaining ring and make it pull backwards. So let's go ahead and place those screws. And again, I'm going to have Inventor do it for me by clicking on place and clicking place from Content Center. And we're going to go back to fasteners, and this would be in a bolt. And I want a countersunk bolt, and it gives me a ton of options. I'm going to scroll down and select a, where is it? A cross-recessed flat countersunk head machine screw type 1 inch. So double click on it, and it's now going to ask me to select a hollow cone to place it in. And then we can change the length of it. We want it to be 5/8 of an inch long would be perfect. That'll give us enough bite into our jaw. And click OK, and click OK again. And there's our screws. So we can do it on the other side now. And it keeps everything the same because it assumes you want to use the same tool. So I just clicked on one of my surfaces and then click apply. And there's those screws. And there we have it. This now goes in and out perfectly. And that will actually stay there if we made it in real life. So let's go ahead and check our mass. So your updated mass should now be 17.937 pounds. Let's save it. And we are done then.